Now let's look at rate of change and how we use differentiation to tackle problems relating to rate of change. So to do this, let me first describe the general concept. So if y is equals to f of x, then dy dx is the rate at which y is changing with respect to x. WRT, anywhere you see it, means with respect to x. So as we've been discussing so far, when we see dy dx, we are trying to study the rate at which y is changing with respect to the quantity x. So now there are two ways this can happen, or there are two ways this relationship can play out. So if as y increases, the value of x increases, that is, there is a direct relationship. When y increases, x decreases, or the converse, that is, when y decreases, x also decreases, then you see that the rate of change dy dx is positive, and positive means is greater than 0. On the other hand, if you have an inverse relationship, that is, as y decreases, the value of x increases, or as y increases, the value of x decreases, then we say that dy dx is negative or is less than 0. So how do we use this concept? So now I'm going to use a practical example to describe this concept, and I'm just going to talk about this example in particular, or this kind of rate of change, because this kind of question that mostly comes out in JAMB. So now let's consider this expanding cycle. So you start out from the center, this point over here, and as time progresses, the cycle keeps expanding, that is, the radius keeps expanding. So let's say after 1 second, you have a very small cycle like this. Then after 2 seconds, the size of the cycle increases. Then after 3 seconds, it increases. So what is happening? The radius of the cycle is increasing with time. So now, as we can see, as the radius of this cycle is increasing with time, what is happening to the area of the cycle? The area of the circle is also increasing, as you can see, and it's becoming bigger. So now, how does the area increase with time, or what is the relationship between the rate of increase in area with time? So that is what I mean by the rate of change. So now let's try to look at a practical example to see how we figure this out based on differentiation. So in this example, we are told that the radius of a cycle is increasing at the rate of 0.01 centimeter per second. So in differentiation term, I can write it as what? The rate of change of radius with respect to time, because I can see the unit here is centimeter per second. So I can write dr over dt is equals to what? 0.01 centimeter per second. Now we are told to find the rate at which the area is increasing, that is with time. So we are told to find the rate of which the area, and I'll call A the area. So d over dt is what we have to find, and we don't know it. Told to find d over dt when the radius of the cycle is 5 centimeter, when r is equals to 5 centimeter. So how do we go about this? So now we know, and we can find the area of the cycle. We know that the area of a cycle is given by the formula what? Pi r squared. So now we can find the rate at which the area is changing with respect to the radius by differentiating this formula A with respect to r. So if you find the A over dr, we just have to differentiate this expression with respect to r. So this, in this case, our r just represents our x. So when I differentiate, pi is a constant which is 3.142. I bring these two down, so I have 2 pi r, because the power reduces by 1. And if you can see, this formula represents the formula for finding the circumference of a cycle, and that defines the way the area changes with respect to the radius. So now, if you recall our discussion when we talk about the chain rule of differentiation, we said that to find dy dx, talked about that finding dy dx, we can introduce a third variable and find what? Dy over du, and multiply du over dx, and we say that du will cancel du. So we can apply the same logic over here. In this case, we are trying to find dA over dt, which is the rate at which the area is changing. So we can write dA dt as the product of what? dA over dr which you found here, multiply by what? Dr over dt, which you are given. So dr can cancel dr and we are left with d over dt. So what is dA over dr? We have found dA over dr to be given by what? 2 pi r, and we found dr over dt to be given as what? 0.01. So what do I have? So I have my dA over dt, and I'm told now that when the radius is 5, so I substitute, I have 2 pi r times 0.01. So when r is 5, I also substitute the value of 5 over here. So I have 2 times, and I'll take pi as 3.142. 3.142, my radius is 5, then times 0.01. When you punch this into your calculator, you get 0.3142, and the unit will be what? Centimeter squared per seconds. The unit of area is centimeter squared, and the time of seconds of time in this case is seconds. So to recap, what did we do? We applied the chain rule of differentiation. So we are given the rate at which the radius changes with time as 0.01. So what did we do? We found the rate at which the area changes with respect to the radius by differentiating the formula for the area of a cycle. So we found dA over dr to be 2 pi r. Then applying chain rule, we said that d over dt will be equal to d over dr times dr over dt, because dr will cancel dr and we are left with d over dt. So we found d over dr to be 2 pi r, and dr over dt in the question are given to be 0.01. So when we substitute the value of pi as 3.142 and the value of r as 5 as given by the question, we found the rate at which the area to be changing with time, d over dt, to be 0.3142 centimeters squared per second. So this pretty much sums up the idea of rate of change, and basically if a question with regards to rate of change is going to come out, is most likely going to be in form of this expanding cycle. So I would suggest that you really understand what we are doing here. So in the next section, we are going to be looking at minimum and maximum points. So that will be all for now. Bye.